Now let's see if we could quantify these forces and fields. Well, we already know that the gravitational field, which I just showed by E of g, is equal to g times the mass m, which is responsible for the creation of this field, divided by r2. And r is the distance from the mass. And obviously, the more distant you are from the mass, the less the strength the field would be. Now, if you put a new mass m in this field, the force on that mass would be equal to the magnitude of that mass times the gravitational field resulted by the capital M. And if we substitute, this would be equal to G times M times the big M divided by R2. Now we want to see what would the equation for our new field would be. So we say for this new field, if we want to go with the same pattern of the gravity, we would say that it would be equal to some constant, just like the g here, times whatever was in charge for the creation of that field. So let's just call it q. Whatever that charge would be, that we just called it charge for now, and we don't have any information about what that is. Since it was in charge, we just call it charge, divided by R2. If they go the same way with the gravitational field, we expect to have such an equation. And therefore, if we put a new charge in this field, we expect the force on that new charge to be equal to Q times E, which is generated because of the BQ. And if we substitute, this would be equal to K times Q times the BQ divided by R2. So even though we don't have any information about what this new field is and how it is generated, by only approximating that maybe it would have the same behavior or the similar behavior to the gravitational field, we were able to predict its behavior and maybe have some equation for it. In the next lecture, we want to exactly explain what these charges are.